Assalamualaikum. We from Group A7. We will present Stretchable Conductive in SCI under mechanical factor. Okay, I will explain about project summary. The SCI development is a great replacement as the alternative way to overcome their flexible and stretchability. Conductive ink are composed of conductive filler, binder and solvent that give electrical conductivity. The ink are produced with special formulae to provide the best performance for specific printing process. The selection of metric filler and substrate based on mechanical properties, which are thermal conductivity, hardness, fatigue strength, shear strength, tensile strength, and shield strength, that are be used to manufacture low-cost and high-performance electronic devices. To conductive ink components are non-toxic and environmentally safe.
Next, the introduction. For the background study, it starts from the realistic. Printed circuit board is used widely in electronic device, but it faces some problem due to a rigid electronic device that cannot be bent, twist or stretched. So it is not applicable for some device. Then it's upgrade to the flexible printed circuit board that can be bent at some point until it fatigue, but it still cannot be stretched. Next, the electronic device is upgrade to the stretchable conducting ink to make it more stretchable, so it can be used in the multi-purpose.
For problem statements, the performance in terms of mechanical, electrical, thermal performance need to carry out in order to establish the SCI by using the new formulates.
Ceramic metric and C intentionally incorporation of one or more distinct ceramic phases enhance wear resistance, thermal and chemical stability, overcome the brittleness and low toughness impairing industrial potential. Polymer metric and C fillers serve the role of nanocomponents, could be one-dimensional linear CNTs, two-dimensional layered, and three-dimensional powdered morphology and silver NPs. High thermal stability, improved mechanical properties, and lower gas permeability for the metal metric and C is a multi-phase material consisting of ductile metal or alloy matrix having some nano-size reinforcement material. Major properties include high ductility, toughness, strength, and Young modulus. Significantly, it used in aerospace, automotive, and defense industry.
All the material will mix together by using thick mixer at 400 rpm for the 10 minutes. This process will call mixing process. As the final result from the mixing process, we got final mixers for the 5 microohm and 50 microohm. Before we apply the final mixers on the TPU, prepare the TPU substrate with the scotch tape and clean any dirty gently by using acetone. After that, apply the ink on TPU by manual printing screen process. Then put it into the mermer oven for the curing process.
Next, I will be presenting about the material characterization. The material characterization will be determined by running the test for the subjects. First is the mechanical test, cyclic stretch test. The stretch test is performed on substrates such as TPU and PET to evaluate the electrical performance of stretchable conductive link for every 1000 cycle to 5000 cycle until it is fatigued. It is important to determine the flexibility of the substrate with the filler after a few cycles of the test. The experiment is set up as in the picture for the stretching test. The holder detached from the body, making it easier to attach the circuit, and that both holders will clamp both sides of the circuit, and then when the spindle is turned, the main body will push the secondary body, causing the printed circuit to stretch, and then the lock mechanism will allow the test to rig the hold to hold the position when it is needed. For thermal test in figure A, this one, the conductive link sample, it is heated from low temperature and then intermediate temperature and high temperature for 30 seconds. Then the sheet resistance was measured using 4-point probe, as in the picture before. That is the 4-point probe, and the reference points for the test in thermal test is the temperature room. Is the room temperature, which is 22 degrees Celsius. And then for figure B, the strength test, the sample was stretched at different levels in room temperature condition, and then the sample is stretched under the strain level of 0%, then 20%, 40%, 60%, and 80% of the strain. The initial length of the sample, which is 20 mm, and then the samples were stretched until it reached the maximum length, which is 36 millimeter. And then the sample were set to stabilize for 30 seconds before the resistance was measured at each strain level. That is for the strain test. As for the thermal strain test, the test is done by stretching the links at various levels, as in strain test in the figure B, and then it will be done by concurrent heating from room temperature and then to the low temperature, intermediate temperature, and then high temperature for 30 seconds before deploying the 4-point probe to measure the resistance.
Next, we move to the conclusion. First, we take a look at the recent advance in stretchable conductive ink technology. Based on the study that were conducted by many researchers, they show that the surface quality of the SCI on the substrate play an important role in achieving the outstanding electrical and mechanical properties, especially for wearable and flexible electronic application, just as shown in the diagram. Besides, the other important factor is cure or sinter. Mechanical and electrical efficiency, as well as product quality, are greatly influenced by curing temperature. Other than that, the mechanical and thermal effect has been intensively investigated for its potential to improve the overall performance of the SCI. Next, we take a look at challenges and opportunities. One of the challenges in developing the SCI is in the printing process. When using printing methods such as screen printing, it is difficult to control the thickness of the printed pattern, which mostly determined by the stencil thickness. Additionally, there is a challenge in creating extremely viscous and concentrated graphene deposition due to the graphene natural inclination toward aggregation. As for the opportunities of using SCI, SCI can be used to cut the PCB manufacturing cost. The ink can be used in many applications to create a thin, elastic, form-fitting circuit for wearable devices. Besides, a low-cost and quick method of producing the SCI helps to reduce the total production time and expense. That's all from our group. Thank you.